How to find exact values for 30-degree reference angles. Let me start with some background information. Imagine you have an equilateral triangle. So all three angles measure 60 degrees, and all three sides are the same length. I'm going to say that each side length is 2x. Now, I'm going to drop a perpendicular from one vertex across to the other side. And when you have an equilateral triangle and you do that, dropping the perpendicular actually cuts the side in half. So then this length right here is x. So if I focus on just one side of this triangle, let's say I'm focusing on just this right triangle part. I'll draw it again over here. What we know now is we have a 90-degree angle, a 60-degree angle, and a 30-degree angle. So we call this triangle a 30, 60, 90. You could turn it around in any kind of way. It doesn't have to be oriented like this. And what we know about the sides is that the short leg that's across from 30 has length x. The hypotenuse that's across from 90 has length 2x. And then if you were to compute the length of the third side using the Pythagorean Theorem, and I'm not going to go through all those steps, but if you did, you would get x times square root 3. So what we like to do, just to make things easier on ourselves, is let's imagine that x is 1. So if x is 1, then for the 30, 60, 90 triangle, we will have a short leg of length 1, a long leg of length square root 3, and a hypotenuse of length 2. I like to say the sides are 1, 2, square root 3. And that's going to be the basis for everything we're about to do. Okay, so imagine you want to know the sine of 30 degrees, the cosine of 30, tangent, and so on. Let's say you want to know all of those or just some of those values, but you're not going to grab your calculator and plug it in and get a decimal. Instead, you're going to find the exact value. Here's what you do. Start by drawing your coordinate system and put a 30-degree angle in standard position. So initial side on the positive x-axis, go counterclockwise 30 degrees. Drop a perpendicular from the terminal side, and you've made a 30, 60, 90 triangle. And we just saw in the background information that every 30, 60, 90 triangle has the following side relationships. Across from 30 degrees, you can put a 1. On the hypotenuse, you can put a 2. And then on the long leg, which is across from the 60-degree angle, you can put a square root 3. Now, based on those values, it's time to compute all of the trig values. We know that sine is opposite over hypotenuse, so that would be 1 over 2, 1/2. We know that cosine is adjacent over hypotenuse, so that would be square root 3 over 2, square root 3 over 2. We know that tangent is opposite over adjacent, so that would be 1 over square root 3. And that needs to be rationalized. So if you multiply the top and the bottom by square root 3, you get square root 3 over 3. Cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, do hypotenuse over opposite, and you get 2. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, you do hypotenuse over adjacent. That gives you 2 over square root 3, and that needs to be rationalized. So when you multiply the top and bottom by square root 3, you're going to get 2 square root 3 over 3. Cotangent is the reciprocal of tangent. So instead of opposite over adjacent, you do adjacent over opposite, and that gives you square root 3 over 1. So just write square root 3. Okay, now imagine that you want to find the exact values of 150 degrees without grabbing your calculator, without approximating. So what you're going to do is you're going to draw your coordinate system. And you're going to figure out where 150 degrees is. So put it in standard position, initial side on the positive x-axis, and then go counterclockwise 150 degrees. That makes a 30-degree angle with the horizontal. And every time you're calculating exact values, you're looking at the triangle that you make with the horizontal. So drop the perpendicular, you have a right triangle, and the reference angle in the triangle is 30. So even though I'm interested in 150 degrees, it's 30 degrees in the triangle that I'm working with. That's called the reference angle. Now, the side length relationship is the same as it was before for 30, 60, 90. We have 1 across from the 30, we have square root 3 across from the 60, and we have 2 on the hypotenuse. Keep in mind, though, we've learned already that in quadrant 2, because we went left, anything that uses the square root of 3, or anything that uses the horizontal side, because of the anything that uses the adjacent in its computation is going to need a negative because going left is going in the negative direction. So what I like to do is just put a negative on that side. That doesn't mean the length is negative, it just means that we have a negative direction, so we need to incorporate that into the exact value. Okay, so the sine is going to be opposite over hypotenuse, so 1 over 2. The cosine is going to be adjacent over hypotenuse, so negative square root 3 over 2. The tangent is going to be opposite over adjacent, so 1 over negative square root 3. And when you rationalize that, you get negative square root 3 over 3. The cosecant is the reciprocal of sine, so hypotenuse over opposite, and you get 2. The secant is the reciprocal of cosine, so hypotenuse over adjacent, 2 over negative square root 3. Rationalize that and you get negative 2 square root 3 over 3. And the cotangent is the reciprocal of tangent, so adjacent over opposite, negative square root 3. So anytime you need to find any of those values, you're going to draw the picture, make the reference triangle, label the sides, and then you can find any of those numbers you want. Okay, now let's say you're asked to find some exact values for 210 degrees. So once again, draw your coordinate system and find where your 210 degree angle is in standard position. So initial side here on the positive x-axis, go counterclockwise all the way around 210. And that makes a 30-degree reference angle because you're 30 degrees past the horizontal, so 30 degrees past 180. Drop the perpendicular to give you your reference triangle. Label the sides 1, 2, square root 3. And because we went left, we need a negative to indicate direction on the adjacent. And because we went down, we need a negative to indicate direction on the opposite. Now we go through the same procedure you saw earlier. So sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Negative 1 over negative square root 3. You'll get a positive because you're dividing a negative by a negative. And then you're going to rationalize it, so square root 3 over 3. Cosecant, hypotenuse over opposite, 2 over negative 1, so that's negative 2. Secant, hypotenuse over adjacent, 2 over negative square root 3. Rationalize it and you get negative 2 square root 3 over 3. And cotangent, adjacent over opposite, negative square root 3 over negative 1. The negatives cancel and you just have square root 3. Okay, now let's imagine that you need to find some or all of the exact values for 330 degrees. So, draw your coordinate system and put 330 degrees in standard position, initial side on the positive axis. Go counterclockwise, 330. And that leaves you with just 30 degrees left. Drop a perpendicular, you get your reference triangle. And there, once again, we have a 30, 60, 90 triangle. So we label the sides 1, 2, square root 3. And because we went down, we need a negative on the 1 to indicate direction. Now we're doing the exact same things we've been doing for all the other quadrants. Sine is opposite over hypotenuse, so negative 1/2. Cosine is adjacent over hypotenuse, so square root 3 over 2. Tangent is opposite over adjacent, so negative 1 over square root 3. Rationalize it. Negative square root 3 over 3. Cosecant is hypotenuse over opposite, so negative 2. Secant is hypotenuse over adjacent, 2 over square root 3. Rationalize it. 2 square root 3 over 3. And cotangent is adjacent over opposite, so square root 3 over negative 1, so negative square root 3. Okay, so just so you know, you can also use these ideas to get angles that are greater than 360 degrees. So for example, imagine you are asked to find the sine of 390 degrees. 390 is coterminal with 30 degrees. They're in the same place. So if you picture the graph for 390, start on the positive x-axis, go all the way around 360 degrees, and then go 30 degrees more. Your reference triangle still just has a 30-degree reference angle. So all the exact values for 390 will be the same as they were for 30. Sine of 390 equals the sine of 30, and so on. And that's true for all the other ways you can work with coterminal angles. Okay, so that takes you through the process of finding exact values for 30-degree reference angles. And what will happen usually is you're just given random problems like find the tangent of 150. So you just figure out that one value. Or find the cosecant of 330. You draw the triangle and figure out that one value, and so on. So if you are doing tangent 150, draw the picture, 150. It takes you over to here, leaving you with only 30 degrees left. 1, 2, square root 3, put a negative on there. Tangent is opposite over adjacent. 1 over negative square root 3 is negative square root 3 over 3. So that's the only one you have to worry about if that's the only one you're asked for. If you're asked for cosecant of 330, draw the picture, put your 330-degree angle in there, counterclockwise all the way around. And that leaves you with 30 degrees in the triangle, so you know it's a 30, 60, 90. Put your 1 and your 2 and your square root 3, a negative on the 1 to indicate the downward direction, and then cosecant hypotenuse over opposite, and you get negative 2. Okay, thanks guys. That takes care of this how-to video.